We will now take a look behind the curtain and see some demonstrations of what Gaia X will mean in practice. Let's say, imagine Gaia X like a huge startup. There are first ideas as well as concrete projects in the pipeline. We have asked 3 speaker teams to share their drafts and concepts to get a glimpse what Gaia X is heading for. Let's start with Mr. Pierre Grandlier from Lyon, Solution Architect, Data AI, Grid Computing and Hydraulic Engineer, OHV Cloud. And from Dresden, Mr. Dr. Ronny Reinhardt, Team Lead Business Development at Cloud&T Technologies. Gentlemen, I hand over to you and your presentation.
Thank you very much and welcome to our presentation on federated services. We would like to present the current status and the outlook from our community implementation project. And maybe by coincidence, Pierre and I each presented separate demonstrators at the last Gaia X event in June. And now, as you can see, we're jointly presenting today, and this is also demonstrates that we are now growing into one group. And so while the previous demonstrators have been good showcases, we've now moved the initial ideas into a community implementation project.
Thanks, Ronny. Yes, indeed, this group is actively working on the blueprints and the implementation of the GAIA X policy and rules into the core federated services to have data sovereignty and data self-determination, as we explained earlier. So I will also to invite people to join and to join us in this effort. But first, let's start with the beginning with the video we prepared.
The Gaia X vision focuses on connecting previously isolated data, having control over one's data, and true transparency of the underlying infrastructure to enable digital sovereignty and making the most of our data. To achieve this, we have to rethink our digital infrastructures. Currently, data are often isolated from each other. For example, you could have data from an engine, from the machine with this engine, and from the factory with this machine, all separated from each other. But we can create substantial benefits if we are able to bring the insights from these data together. So the first challenge we're trying to solve is that we need a mechanism that enables consumers to find offers according to their needs and at the same time allows providers to describe their offers. For example, a company may search for a specific AI service. However, this company has requirements regarding security, geolocation, certification, and sustainability. On the other hand, providers need to describe their services so that consumers can find and select them. The missing piece here is the Gaia X portal with the trustworthy self-descriptions. In a predefined but extendable framework, providers describe their services and consumers can search a catalog that includes these self-described services to find exactly the one that meets their requirements. So self-descriptions make services and providers transparent and comparable. So consumers could be searching for generic services like compute or storage, or for more specific services like machine learning infrastructure. Providers can describe and offer their services through Gaia X. Note that Gaia X itself will not provide services. Instead, it seeks to create a vibrant ecosystem of consumers and providers. Now let's take a look at the current setup of self-description, catalog, and UI. As you may know, Gaia X is a federated system of services with specific policies and rules, and providers and consumers must follow these rules. All self-descriptions will be stored in a distributed storage system. This storage system can then be used by different catalogs with unique UIs and APIs. In addition, we will also provide a hybrid version of identity and access management with decentralized identity management and OpenID Connect Federation services. What we see here is the current prototypical setup in the community implementation group. In the next minutes, we would like to demonstrate how to use Gaia X, in particular, how to describe a service as a provider and how to search for a service as a consumer. And for that, I would like to hand over to Pierre.
Thank you, Ronny, for the presentation. And now let's jump into the second part of this video, where we will have 4 parts. The first part is about the self-description file and how we are building our community. The second part is about the database, which one did you use and why. The third one about the portal, the UI and how to navigate through the data. And the last one, which is a key aspect of GAIA X, how we plan to build this chain of trust. Let's start.
Following the high-level overview given previously, here is the presentation of the GitLab repository, which is used by the GAIA X community to develop the portal. This repository in particular contains the self-description file. The self-description file, that we can also call a manifest, is a description of your service and entity and organization. To submit your manifest or self-description, you will have to open a merge request. The merge request will automatically trigger a pipeline checks. In this pipeline, you will have a syntax check and a shape constraint language checks. Then, before merging into master branch, we will do also quick manual checks to verify that the format complies with the rest of the description that has been submitted before. Now, if we browse the file, you will see that the self-description or manifest are stored in a folder named instance under implementation folders. At the moment, the providers and services folder are the one being used. In the provider folder, you will find the self-description of the providers. We have at the moment 25 provider manifests. In the service folder, you will have the service description from those same providers, and we have at the moment 31 service descriptions. Now, if I go through one of those files, I will take the example of Cloud 98, which is a virtual description. You will see that there is 2 sections. Mandatory properties, which is the direct translation of the GAIA X policy and rules into concrete field that must be filled in. And another section with optional properties, where the provider is free to register any additional information in his description of the provider, organization, or services. We need to stress that this implementation is evolving really quickly, and this section of mandatory fields is obviously not the final one. This list of mandatory fields will grow over time to align with our political ambition and make sure that the GAIA X policy and rules are correctly implemented. Those fields will ensure, for example, that data can be stored and processed in Europe, and this machine-readable file can be demonstrated against tools like the CISPE Code of Conduct. The same demonstration can be done also for the service instances. For example, an AI service where you will have a link from the service to the company that is providing these services. Same thing with mandatory field and with optional field. This collection of provider and services file is being used to populate a database that will power the portal demonstrated a bit later.
And now that we saw what is the raw format, let's see how to use the database. So far we saw what type of file format we want to use and where do we want to store them, how to do the onboarding of people who would like to provide their subscription into the GAIA X, initial GAIA X pool of subscription, which is a very good step forward. The next step will be to extract and to load those self-description in catalog, and the catalog will be powered by a database. The type of database that we selected is a graph database, and it enables us to load the self-description, which are triple stored type of data, into a graph. There is an automatic pipeline that every hour loads the latest self-description into the database that is running on a Kubernetes cluster. The Kubernetes cluster itself is deployed on top of a cloud sovereign stack. And I'm going to show you how the raw file that we saw earlier is going to be translated when we open a visualization of what is inside the graph database. Please be noted that the tool we are going to use is specific to this demonstrator, and everyone is welcome to implement their catalog on top of any database of their choice. So once all the data is loaded into the database, we can open a visual representation of the data and generate this type of graph. Here I'm going to look for every triples and display them. At the moment in the database we have about a bit more than 567 if I remember correctly type of node and attributes. And we can see here that it's not tightly coupled, but we start to distinguish some chain of services that depends from each others, which is the start for growing this GAIA X community. As a summary, we saw the first part, how we wrote the self-description. We saw how it's presented into a database, a catalog, and now we will have the demonstration of the UI that sits on top of the catalog, and also a bit later, how do we ensure this chain of trust between independent declaration of services and providers. Finally, we will go through the portal and the UI that we've developed. And now the long-awaited GAIA X portal demonstration. This portal is a catalog of the provider and services self-description that we saw earlier, which are stored at the moment on GitLab. This is a search catalog, and this is not a broker or a scheduler. So all the information that you see in this catalog are not meant to be replacing the integrator or the cloud service provider. As a reminder, GAIA X is not a cloud service provider, and GAIA X is not a cloud management platform. On the main page, you have a search bar and some news from GAIA X ecosystem. On the left panel, you have two sections, services and provider. If we go first on the provider panel, you will see the list of all the providers that are currently registered in the database with real data. And you will see also some filter on the left side by location and by headquarter location. The second tab is about services. On the services, as expected, you have the services self-description and information. Same way that for provider, you have a list of filter on the left panel where you can select which output you want to consume, what does it consume for handling the dependencies, and who is providing them. Please note that the results that are displayed are randomly ordered. There is no alphabetical nor preferences. If we take the example that we had earlier for the provider and Cloud 98, we see here the same level information in a nicer way. The location, Sweden, certificate, the last update, and the membership date. We also can see right away in this UI the services that are managed by this provider. Here it's a green managed Kubernetes offer. Let's assume that now you want to look for an AI service. You will, of course, be able to see that it's provided by the AI company, that it's GDPR compliant with some description. But more importantly, you will see that the dependency is using. So this AI service is using Cloud 98 green managed Kubernetes offer. And you click on the small lens here to have more detail. This service, it's its turn, is using secure OpenStack, provided by another provider. And here you see that this dependency is also GDPR compliant and has some tag information about the provided service. Doing so, you are able to unroll all the dependencies and check that each of those layers comply with the requested information that you are looking for, and also GAIA X policy and rules. And we can go as deep as we want. We have here, for example, the data center expectations, and for example, inside the data centers, where are the servers coming from? I hope you enjoyed this demonstration of how you can check the chain of trust that you have when you are going to look and consume a service. More detail about this chain of trust in a few minutes.
Thank you, Pierre. In the GAIA X philosophy, there can be different GAIA X catalogs. Using the distributed self-description data, anyone can create a catalog based on a specific target market, in particular application type, or any use case. Here we show one example of such a catalog, which has been built specifically for AI application services in Saxony, Germany. The users can search for an AI application according to their needs. The catalog of AI applications is using a subset of the same self-descriptions used in the catalog which Pierre has just presented. Before the deployment of the application, the user provides the criteria for the underlying infrastructure in terms of location of data processing, location of the provider, certification, or sustainability-related criteria. As you can see, the application selection and the user's filter mechanisms have been implemented in a different way than the main catalog to address the specific use case in this catalog. So, in the GAIA X ecosystem, various catalogs can coexist to solve specific use cases. Back to you, Pierre.
And to end this session, the last technical bits will be about how do we plan to build this chain of trust. And now we are going to view a very important part of GAIA X chain of trust. To start this example, let's assume that we have a provider here in green issuing two subscriptions B and C. The issuer will have to sign the subscription claiming those are mine. The next step will be to ensure that the GAIA X policy and rules are embedded inside those subscriptions through the mandatory field that we saw earlier. If we have another provider here in blue issuing a subscription A, the provider can state that he's depending on provider B and C, and he will also sign his subscription saying, I declare that. As for the other providers, the subscription A will have to comply with the GAIA X policy and rules through the mandatory field. Last, to verify that this chain can be trusted, we can involve an external third-party certifier that will come and check that the declaration made by those providers comply with actually what's happening in the real world. Then the certifier can sign the subscription A, B, and C, ensuring that they comply with the policy and rules with additional certification, and it can be trusted.
Thank you for watching this presentation. As presented, this is a community effort of implementing GAIA X policy and rules into the self-description and core federated services. As we are working on the blueprints of the core federated services, come contact us and join us in this effort.
Yes, and as already, there are quite a few organizations and individuals working on implementing the GAIA X vision. There are also other teams working on different aspects, and in the next two presentations we'll see how people are implementing a vision for a specific domain, such as smart living, or for an important technical aspect, such as interconnection. So thank you for watching this, and feel free to reach out and join our effort.
Thank you for your presentation, Herr Dr. Reinhardt et Monsieur Grandlier. It's a pleasure for me to welcome now Ms. Dr. Sabine Wilfing, Unit Lead Public and Government at SHARE, and Mr. Thomas Feld, Managing Director at Strategion.
My name is Sabine Wilfing. Welcome. I'm having a pleasure to give you some insights together with my colleague Thomas. So I'm also happy, as Ronnie said, I'm not alone this time. I will talk about the aim of GAIA X, how GAIA X is creating a data ecosystem in Europe that will generate innovations and new data-driven services and applications, as Mr. Jatzambek said. So on the first, I will highlight a little bit the challenges companies have, like startups in AI projects. Then I will go over and explain it on how GAIA X helps to unlock the opportunities offered by data economy. And in the third step, I will explain on the federated services, how they can support an end-to-end engineering process across the whole GAIA X stack to develop and innovate smart advanced services. Last but not least, I will give just a short snapshot into the smart living domain, and I'm very pleased to have my colleague here, Thomas, the ambassador of smart living domain, who will then show on a concrete example of smart living how a smart service engineer in an AI project has created really hands-on smart living services for more sustainable and friendly living. So let's get started. More or less, we have due to the cornerstone of current transformation in our society, it's data. And the goal of every company is raising value through AI and data-driven cross-sectoral business models. So where are we today? So the digital transformation of value creation changed massively. In the past, we had collaborations in linear supplier, more or less orientated value chains. That was common with the development of physical products and services. The key objects mainly of that collaboration, that was reducing cost or increasing efficiency within classical linear chains, as I said. But today, new technologies like AI, like data, they changed that setup massively. We need to integrate these technologies like AI into the value chain and into that creation of products and services. We need to develop new products based on data. That is key. So, and more or less, we have centralized and decentralized collection of processing units, various data. We have cloud application like PaaS, software as a service, infrastructure service, and IoT. So companies are embedded and involved in a very complex value-added networks, and they have to find out what they can successfully make out of that data for the customer and what data-driven business models look like, mainly cross-sectoral. So to sum up, the companies have to redefine their value creation. Service engineering is becoming more and more important, where value is generated by a number of services, data sources, and so-called advanced smart services. Let me give you a short example on advanced smart service. Advanced smart service combines physical and non-physical parts. For example, when we look at agriculture, then a service combines classical field work together with data processing. Today, in former times, for example, the machine and also the man steering that machine doing the field work, they were at time X on the field doing that job. But what is today? They need to prepare the machine and the driver, and they need to prepare all that data for the operation, and then based on weather, on growth, on different data, this time point is set to bring the field and also the machine and the man out to the field. So what are the challenges for those AI projects to gain data-driven innovation and to force that strategy and to develop in the end a trusted and sustainable economy? So the problem of AI projects, why they often fail, it's mainly trust and data. So to set up an AI project successfully, data value chains are the prerequisite. Consumers and providers, they need to work closely together to understand the business needs, and they have to get into close collaboration in a trustful environment. Only if there are no insufficient mechanism to secure and to get trustful access to data, they can exchange and they can get into these AI projects. So in AI projects, they need to get to that massive amount of data. They need to prepare them. They need to analyze and model them to train the AI algorithms. They need to do some evaluation and monitoring. And the key is to have these data and to have these trust to exchange it. So missing trust and missing data leads to the stuff we have at the moment. So a sovereign data exchange is not possible. We don't know which services, which nodes, which providers, who is providing what data, and which service can I use to extract. We have also challenges in compliant AI services and storage services across the stack. And in the end, identity and trust management is really important to deploy that service in the end. So to sum up, flexibility, speed, agility, and standards, these are important parts to build up the foundation for like a data-driven innovation strategy and to have successful AI projects. So how can GAIA X help and solve this? Let me explain it a little bit on the GAIA X architecture itself. So providers and consumers, they find out how they can share data and use that data for solving a certain problem. And they gain ideas on how can data-driven business models look like. So GAIA X is solving that with an architecture that is enabling the shift like from a data silo thinking to a data ecosystem, enabling like mechanisms to share process data across different parties in a trustful and easy and interoperable way, from an infrastructure level, the Rev 1, up to a data ecosystem level. And there we have like the possibility to gain end-to-end service engineering processes. I think that is the most important thing, to have these service engineering processes end-to-end from the infrastructure up to the data ecosystem, to advance like the digital sovereignty in two ways. On the one hand, by offering like with GAIA X governance framework, which offers mechanism to, on the one hand, that data can be stored, trustful, and also can be processed in Europe in a sovereign way, according to rules and mechanisms and standards. So cloud and data services are more or less like the key element of our digital sovereignty, and the industrial data we have and we need for the AI projects, they're the critical input factors for that. Let me give a short intro into the architecture, as here also on the example of the smart living domain. So if we go further, I will explain that whole stack engineering process a little bit more in detail. So when we look at the architecture, we have in the bottom of the architecture from a technical point of view, in the smart living domain, if we position it already in that example, the infrastructure is characterized by like distributed data sources, very heterogeneous system landscape. We have data assets of the individual like smart living providers and consumers here across a very wide variety of clouds and on-premise systems like security clouds, you see it here, data center of housing provider, mobility cloud, engineering cloud, and so on. And if we go upper in that stack to the data ecosystem, there the digital sovereignty of the data owners are preserved. So in the blue area up there, you see the smart living data spaces forming a data ecosystem. They're bringing together different kinds of data, like environmental data, smart device data, biometric sensor data, and so on. So the main benefit is to bring that unconnected domains and partners, such as like housing, energy, and building provider together, to make it possible that AI projects can be set up to develop cooperatively across these boundaries, smart advanced services, like in the context you see it up here, smart security, comfort services, mobility services, and so on. So last but not least, let me say the innovation potential in smart living domain is really huge. We have like a big global market growth. You see it here in 5 years. There's a really ramp up. I think that makes it again clear that we need to address these challenges from an innovation side to go further. And I think, GAIA X has the chance to drive these data-driven innovations and strategies and to develop a trusted and sustainable economy with a combination, and that is, I think, very special, of a technical and also data infrastructure, which creates like a unique constellation, you can say it, of data valorization in Europe. And these two parts, they're like complementary elements, I think, of an EU digital ecosystem. So before I hand over to Thomas, I would warmly encourage you to take part in this moonshot and make it happen, and to play an active role in building up that data ecosystem, getting astronauts on the start, if we stay with the term moonshot, taking part in developing of the architecture, as well as getting involved into the different domains and hubs, and let's bring things together. Thanks very much for your attention. It's my pleasure now to hand over to Thomas, the ambassador of Smart Living.
Thank you very much. Next slide, please. Okay, yes, also warm welcome from my side. Yes, I'm the ambassador of Smart Living, and on the next slide we will continue exactly with the same picture which has also presented Sabine. We must know that our aim is, the aim of Smart Living, to create an energy efficient, sustainable home for each and every one of us. And our European building industry and also the electrical industry are here world leaders. But the next challenge is to make our solutions smart. The key technologies are AI and cloud-based data infrastructures. So I'm really proud to present you today the first joint demonstrator for the first development of an advanced smart system service engineering system based on GAIA X and also on Foresight. So I would really thank in advance to all partners in this project for their valuable contribution. Next slide, please. Well, you can see the both concepts of Foresight and also of GAIA X fits very well together. In the middle, you see the Foresight project platform, which is hosted in Europe in a trusted cloud infrastructure. And with the GAIA X Federation services, we can obtain data from trusted data providers, deploy smart services to the service consumers. And these consumers could not also only be systems, it could be things, it could be people, it could be our business. So we interlink all these different players and actors together in one European trusted data environment. So the most important person we need in Europe is the advanced smart service engineer, not only infrastructure. He's on the upper left and he needs to know what are the available and trusted data sources, and he needs access to a trusted AI database and a trusted AI running system to deliver trustful advanced services for the European Union. So next slide, please. Make it easy. Let's go started. This is an advanced smart service engineer who has to develop an advanced smart service, and he uses Foresight and also the federated services of GAIA X. Yes, let's take a look. We made an easy business example. We all are sitting now on our chairs, probably in our home, and our home is our office. And what could happen, what is more worse, is that we could not start a presentation. More worse is, yes, next click, the postman rings twice. In this situation, we are in trouble and we all would wish, next step, the intelligent doorkeeper takes care of it. That means he handles all the business tasks we are not able to do at the moment because we are in this conference. Next slide. But there's also another situation. We are not always at home. An accident may happen. There could be a water leak. And if we not handle this water leak, then we will have another problem. So next slide, please. Yes, here we need also to let someone in that can handle this case. And also here we would wish that we have, next slide, the intelligent doorkeeper that takes it for it. So it sounds like an easy application, but for a data analyst or the smart service engineer, it is a huge problem. Next. He has to get access to many different data sources, which need to be first found and which need to be trusted. Over 40% of an AI project are going in efforts to find this data, to collect it, and to order it. Here, the federated catalog is the first step to go in. Let's take a look how it looks like. Next. So if I make a pause, you can go to the next slide. We are searching for, in this example, for one service, and we are looking for a water detection service. And we find one here provided by the German Artificial Intelligence Center of the DFKI. We are wondering a bit because they are not producing them, but let's look forward what will happen. Okay, we take this service we have found, and what we see is we have only got a digital twin. That means we can simulate a water leak detection service, but we have not yet a real one found. Therefore, we need to connect a data source to it. And we have a service registry where we can link then also this virtual service to a real environment. Next. And therefore, we need also a sovereign data exchange for the implementation of a trusted service. I have there an animation, click, yes. So we start from the water leak, and this is registered in the register of the AI service project. Now we need to connect this service with the real world. We have at the moment not yet data. Yes, we're looking in the registry and click if I make a pause. Click. The data connector of IDS will link to a real data environment like the Smart Home Lab Sense in Berlin. So that we can, as a data analyst or a data scientist, now work directly with real data to optimize our service. So next slide. I will be a bit short. Okay, let's look in the system. We are now in the registry, and we also found the water leak detection service here in our registry of our AI project. Next. And the information, the description of the service also includes the description of the self-description of GAIA X as well as the self-description of all other services or all other descriptions we need to implement it. Next. We have also seen that we need to connect the service with another cloud. So the description for the international data space connector is also involved and can also be used so that we can use different partners and different centers of data to link this data together. Next. So what we get for the smart service engineer is a trusted and linked data space of all information he needs to implement his advanced smart service. And he gets the context of the process, not only the limited data which is today in the process. He gets all information to answer any question, to handle any situation in the process he needs. And for this reason, it's not only for smart living important, it's for any business. If you have a business problem and you need to design a new smart advanced service, very important that you have access to federated data service provider infrastructure, and you have access to a distribution platform where you can share the services you have created, that you reach your customers in the futures by the combination of advanced smart service engineering and federated service processes. Do you want to join? Last slide. Well, if you come to us, to the Future Living Berlin or to Osnabrück, where we are developing this smart engineering process, or in Gaia X, maybe the intelligent doorkeeper will welcome you. Thank you for your attention.
And thank you for your presentation, Mr. Dr. Wölfing and Mr. Feld. The third demonstration we will see now is held by Dr. Dominik Stingel. He's Project Manager DKIX Management, and there he is responsible for the Gaia X project and works on the topics of interconnection and networking. In the following speech, he will answer the question Gaia X interconnect or connect. Hello.
Yeah, hello, Carmen. Thanks again for having me here. It's also for me a great pleasure to be at the summit. And I would like now to finish our session about the demonstrators with this vision about Gaia X interconnection, connect or interconnect. And yeah, so far in the session, we have seen the federated service catalog, which allows to query and seek for data services. Based on that, we have seen the second talk, which has given a concrete example with a smart living for use case, which is benefiting from the offered functionality of the federated service catalog. Within this talk, we want to take a closer look at the network layer of Gaia X, which shall serve as basis to transmit data, combine services, and may also federate different types of clouds. So last day and today, we have seen many presentations that talked about the immense potential of Gaia X, bringing the European players together. Examples for use cases and data sets from the data ecosystem have been provided. We have seen, for instance, cloud providers from the infrastructure ecosystem. The federated services have just been introduced to glue things together, covering important aspects such as identity and trust, sovereign data exchange, the federated catalog, as well as to ensure compliance. So everything what is necessary to shape the vision of Gaia X, a user-friendly and homogeneous European ecosystem of data and infrastructure service that operates seamless in terms of security, privacy, and interoperability. What is missing is the link in between. So how and by which means are data and information exchanged to make everything eventually happen so that data can be merged and can be moved from one place to another. The clouds or data centers can speak with each other, and everything based on the key principles from Gaia X and the requirements from the use cases. So in the following slides, we will talk about the missing piece of the puzzle, and then we'll have a closer look at the infrastructure ecosystem, more precisely at the network and interconnection providers for a better understanding of the challenges that arise for them. We will take a closer look at the network and highlight how the solution from a network perspective looks so that data can be transmitted and that customers and service providers are able to interoperate and connect with each other. First of all, let us start with a look, how does interoperability between the different entities actually happen? For instance, how are the different players connected in order to communicate? Let us have a look, for instance, at the use case Industry 4.0. In the example depicted on the slide, we may have a small or medium company with its own network. This company, for instance, may generate a huge amount of sensor data, which is too big to be stored in its own location. So to handle the data and probably avoid the costly on-premise storage, the data may be stored at the cloud provider. In order to avoid vendor locking and be more flexible, another type of sensor data may be stored at a second cloud provider. Finally, the company may have a contract with a supplier. The supplier may require access to the data in one of the clouds in order to analyze how its products performs, to do some troubleshooting, for instance, or check other products. And there may be also communication going on between the supplier and the company to inform each other about the current status. Last but not least, the company may also need access to the public internet. For example, to have a look again at the federated catalog from Gaia X to search for new datasets, services, or a new cloud provider. So this is just a rough example of a use case from Industry 4.0 to explain how the different parties interoperate with each other to communicate and exchange data. Let us now take a closer look at what is happening at the network level and how the interoperability is currently implemented on the network level. Taking now a closer look at the infrastructure ecosystem of today, the following can be observed. The company's corporate network is connected to its data center on-premise, for instance, over an additional external network, such as a carrier ISP network. This network in turn, is already connected to an internet exchange point to leverage the benefit of interconnection. In general, this benefit of using an internet exchange, in contrast to going to the public internet, is manifold. You are able to use shortcuts to other entities, such as other carrier ISP networks or data centers. You're able to define the guaranteed bandwidth in the internet exchange that can be used to transmit data to other connected networks. Furthermore, you know over which points your data is routed, as you are directly at the internet exchange and do not have to go through a public network or the internet. Finally, apart from the fact that you know about the path your data is traveling, you also can utilize security features of interconnection, which may be black holing to mitigate DDoS attacks, for example. Now, going back to our example from the previous slide, we see that in this slide that one of the cloud providers, Cloud A, is connected to the internet exchange in a similar way as the corporate network of the company through a carrier ISP network. Cloud A is connected to the internet exchange, thus having an additional network in between. For cloud provider B, the situation looks a bit different. Instead of being connected to an additional network, it is directly connected to the internet exchange. Based on this, cloud provider B is able to leverage the full potential of interconnection by removing the additional level of indirection. With a direct connection to the internet exchange, Cloud B knows exactly how the data travels to the internet exchange, has a reduced latency by being directly connected, and full power of the configured bandwidth at the internet exchange. So for cloud provider B, the benefit of interconnection is much stronger because of the direct peering with the internet exchange. As of now, using the full potential of interconnection, as stated before, is mainly affordable and possible for only a fraction of customers or providers. Smaller customers or providers of GAIA X are not able to benefit in the same manner as, for instance, cloud provider B. There are always additional networks in between as an additional level of indirection. With that situation, it is hard to fulfill the requirements which are derived from GAIA X with its data ecosystem and the federated services. As the paths between potential players gets longer through traversing carrier ISP networks, latency requirements are harder to guarantee and fulfill. Since the parties in GAIA X have to share the network with other participants, bandwidth requirements are also hard to fulfill and to guarantee, as it will always depend on the fact what is happening in addition in the network. A further effect of going through public networks such as the carrier ISP networks is that there is no overview on how the data is routed through the network. There are no means to select which paths or routes should be used in order to avoid that the data, for instance, might leave the European Union. In terms of security, shared networks may pose security problems. You are on a public network and are sharing resources. This means that you are one of many participants and may suffer from problems that a network provider has actually to deal with, may it be, for instance, DDoS attacks. When having a direct access to an internet exchange, you can benefit from means to mitigate, for instance, those DDoS attacks through black holing. You can limit the parties involved in a data exchange through closed user groups, which lets you also decide which protocols may be used to exchange the data. And finally, an important requirement which has to be fulfilled in GAIA X is flexibility. GAIA X envisages a flexible data ecosystem and infrastructure ecosystem where data, services, and resources shall be combined in a flexible and easy manner. This is the idea of a user-friendly and homogeneous European ecosystem. So also from a network perspective, this flexibility has to be provided. So the overall question is how to connect the infrastructure and data ecosystems and federated services, given those requirements from GAIA X. The vision of the GAIA X infrastructure ecosystem on the networking layer is a network which does not only allow for interoperability between the customers and providers, but also allows for interconnectivity. The full benefit of interconnection may not only be limited to a fraction of participants which have the capability to directly connect or peer with an internet exchange, such as cloud provider B from our example. Instead, all providers or customers, may it be smaller or larger ones, should exploit the benefits of interconnection in order to be able to address the challenging requirements of GAIA X. Therefore, the idea is to provide means for every participant to directly consume the functionality of interconnection to offer direct links from the participants to the internet exchange. so that this internet exchange will serve as interconnection platform to the participants in GAIA X. Key elements of this idea are the offered interconnection services, such as peering, virtual private network interconnects, or closed user groups, as well as offering direct layer 2 links through networks to reach an internet exchange. Based on that, the infrastructure ecosystem of GAIA X is able to strive for the requested interoperability and interconnectivity, so that in the ecosystem, data can be transmitted, services can be consumed and combined, and the necessary resources may be federated. May it be in different types of communications patterns like one-to-one, one-to-many, or many-to-many. So apart from the vision of GAIA X for an interoperable and interconnected infrastructure ecosystem, which fulfills the requirements with respect to latency, bandwidth, route selection, and security, an important aspect is flexibility. As seen in the previous talks, customers have to be able to find their required service with the offering provider in order to configure and build their own services and application. This does also account for interconnection. Customers and other service providers must be able to decide which services in terms of interconnection they want to have and how they should be configured. In terms of interconnections, that means, on the one hand, that the services have to be provided in the federated catalog so that they are available and can be searched for. But on the other hand, this means also that deployment and configuration of the selected services has to be done ideally in an automatic way through some kind of interface. As shown by the slide, the interconnection requirements that a customer on an application has needs to be communicated over an interconnection API so that it may be automatically deployed by the underlying internet exchanges or carrier ISP networks to offer interconnection as a service. So therefore, apart from providing interconnection services, an important goal within GAIA X is the definition of an open interconnection API, which offers a dedicated set of methods to define and configure interconnection service. Going back to our example from the Industry 4.0 with the company and its sensor data, its connected data centers and suppliers, this means that the company shall be able itself to modify the settings of the service. For example, if additional bandwidth is required, the booking of additional bandwidth shall be possible. If an additional supplier should be integrated, which shall have access to the data, but for instance, a clean separation already on a network level should happen, then this may also be configurable by the requesting company through the interconnection API. So one way to do this is the interconnection API, which serves as interface to enter requirements and requests, while below the addressed internet exchanges or carrier ISP networks need to deploy these requirements and requests by modifying and provisioning the necessary connections. We can see that in the picture that the different cables, for instance, may be moved from one port to the other to implement the different requirements regarding interconnection. So the important thing of this interconnection API is that this is an API which is usable by everyone. This means that this API can be implemented by different interconnection providers so that there is a possibility to request and configure the services not only for one interconnection provider, but for multiple providers. Based on that, the flexible interconnection is not limited to one single interconnection service provider, but to multiple ones for the provisioning of a European interconnection. For this vision, a future solution may be to leverage the already existing and very good infrastructure of the European Internet Exchange points, such as, for instance, France X, the Dutch M6, topics from Italy, NetNode from Sweden, or DKIX from Germany, for example. Based on this, providers and customers can utilize the offered functionality to implement the vision of GAIA X, a user-friendly and homogeneous European ecosystem of data and infrastructure services that are seamless in terms of security, privacy, interoperability, and interconnectivity. So with this, I want to close my talk about this. Please, if you're interested in the topic of interconnection networking, then please feel free to join our interconnection and networking group so that we can shape the future of interconnection in GAIA X. Thanks a lot.
Thank you, Mr. Stingel. Ladies and gentlemen, time for the lunch break. I have no idea what you are planning to eat, but I'm really looking forward to my spaghetti bolognese now. And we will meet again at 2 p.m. Please feel welcome to use also our talk conferencing tool to get into conversation with the other participants. We've created the break a little longer so that you will have enough time, really enough time for an exchange. Enjoy your meal and see you back.